Okay? So yeah, 3Ds, 3 dimensions, length, width, and depth, right? I have a width right here. I have a height if I stand up, and it is a low height, so don't make fun of me for being short. And I have a depth. The depth is pretty good until you get to my belly. And then it's bleh. But that's okay, because I can still jump higher than that grade 9 kid. Everyone cool?
Yes.
3 dimensions, all right? Now, every 3-dimensional shape that we will deal with in our class falls into one of 2 categories, okay? You already got these, you got the first one in the 9th grade, and depending on who your grade 9 teacher was, you maybe discussed the second one. If you were in my grade 9 class, we didn't, okay? So the first one, the shapes are prisms. Okay, now the prism is a specific category of shape. It is not associated with any one shape or polygon. Does everybody understand? Any polygons can make a prism. Okay? And a prism is simply this. It is a 3D construction. Now, of course, on paper, it will never be 3D, right? It will just appear 3D. It's an optical illusion. A 3-dimensional construction with 2 identical, parallel faces. And they are separated by rectangles. See you later, Larry. Make sure you watch the video. Everybody cool with that? Okay. So this right here is what shape?
A rectangle.
A rectangle. Everyone okay with that? Also called a quadrilateral. Okay? Rectangle. How many dimensions does this have? Nobody be punky and say, well, it's got 3 because it's technically 1 piece of paper thick. Don't be that kid. Okay? How many dimensions does this have? 2. Length and width, yes? Everyone agree? And they are indeed, it is indeed a rectangle, yes? Now, if I take 30 of these and stack them together, do I have the same length and width?
Yes.
Length and width, that is the same. But now I have a depth. Everyone agree?
Yeah.
So what I did was I took this rectangle, and I took the exact same rectangle, right? And I put them parallel to each other, and then I put a rectangle in between. See? Everybody cool? So this makes a prism. Everybody with me? That's all it is. So we're going to draw one right here, the easiest one, the rectangle prism. Just draw a rectangle, then draw a 7 out here, and then connect the corners. Everybody cool? Rectangle prism. Easy peasy lemon squeezy. Yeah? Everybody good? Okay. Next one we're going to draw is the triangle prism. Draw a triangle. Everybody got their triangle? Now draw one line 45 degrees that way, another line 45 degrees that way, and connect them. That is the triangle prism, like a Toblerone chocolate bar. Everybody okay with that? I don't like Toblerone chocolate bars. They can go away. Because hazelnuts are gross. Okay? I don't like hazelnuts. I'm allowed to not like hazelnuts. I also think Nutella is gross. Right? And everybody's all like, oh, Nutella, it's going to save the world. No, it's not. Okay, yeah. Eventually we're going to have cars that run on Nutella, and we're going to heat our houses with it, and it's going to solve the food crisis. No, it's not.
It's just chocolate.
Nutella is not any good. One time, I was living with some buddies. We had a roommate situation, and we always took turns making lunches so the other guys could party. So one guy's job was to make lunches, and one guy in the house loved Nutella. Whenever he made lunches, he always made Nutella sandwiches for everyone. Yeah. And I was pissed off. It's like, man, I don't like Nutella. He's like, to make your own lunch. But it's your night to make lunch. I don't care. I'm making Nutella sandwiches. And I'd eat Nutella sandwiches one day a week. I don't like them. They can go away. Now, I do like the Reese spread, which is peanut butter and chocolate. That's delicious. Okay. Now, the next one that's going to mess people up, people don't ever agree with me, is what shape is this?
Rectangle.
What shape is it now? A cylinder. Is a cylinder a prism? Of course it is, because what's on the top?
Circles.
What's on the bottom?
Circles.
Are they the same?
Yeah.
Are they separated by a rectangle?
No.
Yes. So a cylinder is also a prism. That we draw a squish circle, go straight down, and then smiley face. Okay? Everybody cool with that? All of those are prisms, which means since they are all prisms, they all share similar rules. Everybody okay with that? Doesn't matter what shape it is. Now, the next kind of shape we have are pyramids. Okay? Now, a pyramid is slightly different. In a pyramid, now I'm going to use a word here that always causes trouble. A base shape. Now, before I go any further, I'm going to highlight base, and I'm going to define it for you. It is not the bottom. Does everyone understand that? Everyone wants to make the base the bottom because you guys remember grade 9 and grade 8 geometry where you did a triangle and it was base times height for area, yes? And everyone's like, the base is on the bottom. No. Base is like home base, where you start from. Is everybody with me? So the base shape is the shape we start with. Now that is horrible grammar. You would never say that because that's dangling your preposition. And dangling your prepositions is really, really a bad idea, especially in class, to dangle your preposition. No one? Fine. Anyway, it is the base shape from which, oh, and I just screwed up how I'm writing this. I'm going to highlight the definition here and so I can write around it. From which all sides meet at one point. Now, you guys are all comfortable with the basic pyramid, right? Because we've all seen pictures of Egypt and King Tut. Yes? Even though King Tut was not indeed buried in a pyramid, he was in the Valley of the Kings, but that's another story for another day. The basic pyramid is simply that. You start with a rectangle or a square on the ground, and you get 3 or 4 triangular faces going up. Everybody cool? That's the pyramid we're all comfortable with. Everyone agree? Yes. But it does not need to be that. It can have a triangle on the bottom. And I'm going to put dotted line to show you the back of it as a triangle. And then it comes up and meets at a point. Is everybody okay with that? That is still a pyramid because it starts from a triangle and goes up to a point. Is everybody cool? And then the third one is the cone. Starts from a circle and goes up to a point. Which some of you will call a dunce cap indeed, even though you don't know what those actually are.
There's the ones when you're really stupid you wear.
Yeah, nobody's done that in like 40 years. Because, your feelings are important. We didn't have dunce caps when I was in grade 3 or 4, but the teacher would send you to the corner if you weren't if you were behaving poorly. And then you tried to get out of the corner by behaving better, so it worked. Now what do? We send you to the principal and they take you out to lunch because you're troubled. I'm just kidding. Relax. Parveen.
My teacher had the cats.
Shut up. Really?
He said that.
Where?
South Auckland.
Wow. That's badass. Really? Did you ever get it?
No.
Lies.
Isn't South Poplar a traditional school?
Yeah.
Oh, that's why. Because in traditional school, you can get away with stuff like that. We can't. If I sent one of you to the corner with a dunce cap on, I would be fired so fast. It wouldn't even be funny. It would be on the news. No, I'm not joking, Michaela. Do you guys remember last year or 2 years ago, there's a picture on the front of the paper, the kid with duct tape on his mouth?
Yeah.
Do you remember that kid? The teacher that did that to that kid was my grade 10 English teacher. Yeah. And they didn't bother telling the whole story, of course, because they had to make the kid look like he was a victim. You know what really happens in that classroom? Mrs. Fowler, that was the teacher's name. If you were a dick in Mrs. Fowler's class, like maybe I was once or twice, I won't say, Miss Fowler would say, Matthew, or whatever the kid's name was. Stop it. Oh yeah, Miss Fowler, I got it. Or whatever the kid would say. 2 minutes later, Matthew. Stop it. Okay, I got it. 2 minutes later, Matthew. Yes, Miss Fowler? Okay, I got it. 2 minutes later, Matthew. You are going to do one of two things right now. You are going to take this, and she'd reach into her desk and pull out a roll of duct tape and say, you are going to put this on your mouth, or I'm going to send you to the principal's office. Now, this was 1988. The principal was a scary place to go in 1988 still. It's not anymore, but it was when I was 13. And I chose every time the duct tape. Because I didn't want to go to the principal. Because the principal, not only was he cruel, he would call my mom. And my mom made the evilest television principal that you've ever seen, even from a show in the 50s where they beat you. My mom made those principals look like Santa Claus. And the thought of that principal, who already was the evilest man in the building, calling my mother, who was the evilest woman in the building when it came to discipline, scared the poop out of me. So I took the duct tape every time. Right? You can put on the duct tape or you can go to the principal. Give me the duct tape. Rip. She never touched me. She never put duct tape on any kid. It was always our choice. And every kid took the duct tape. Nobody went to see the principal. That kid, oh, my teacher forced me to put duct tape on my face. And it was front page news for a teacher who's been teaching for 50 years and to this day is still in my top 10 teachers I ever had. I lie, she's top 3. Yeah, and that's what she's going to get remembered for. Not the 50 years of being the best teacher in that school. She's going to get remembered for one crybaby pissant. My feelings are hurt because I had to put duct tape on my face because I couldn't shut up when Miss Fowler was teaching. And his folks supported him. You know what my mom would have done? Why you only put it on his face? Why don't you tape him to his chair? That's what my mom would have said. And then leave him there, make him walk around with it all day like this. That is exactly what my mom would have done. Probably beating me the whole way with a stick. Anyway, times have changed. It's 2016. I have children. I do not duct tape them to chairs. Or do I? All right. Draw and calculate the surface area of a cereal box with those measurements. All right? So first of all, we got to draw it, right? Now, this always causes problems because you guys think that this is an art class and I'm going to mark you for your drawing. I am not. This is not an art class. This is a math class. You have all seen cereal boxes. The front of the cereal box is a rectangle. I'm going to call it Mattios because they're mathematically delicious. Right? I know, right? Now, what measurements are sensible right now? Of the 3 that we have given, what ones should I put here?
8.
The bottom.
The bottom should be what? 8?
Well, 8's the depth.
24. So what should this be? 40. So where should the 8 be?
The depth.
The depth.
That looks.
Everybody cool? Now, for some reason, this unit causes kids trouble. I don't know why. All right? The surface area is the total exposed area of a solid. All right? If I pick up a cereal box and it is closed and I dip the cereal box in paint, will any paint go on the inside of the cereal box?
No.
No. That's why I said it's closed, Joel. So the surface area is only on the outside, correct?
Yes.
Now, looking at this drawing that you have right here, what do you have? You have this rectangle, correct?
Yes.
And how many of them are there?
Two.
2 times 2, because there's a front and a back. Magnus?
You know how you like close a cereal box? There's like that overlap. You have to calculate that too.
No. There is this yellow rectangle. How many of them are there?
Two.
Times 2. And there is this green rectangle. How many of them are there?
Two.
Times 2. Now, you all did surface area of rectangular prisms in grade 9. You all did it. You probably were shown, find that face times that face, and I'll multiply it all by 2. Probably. That's my guess, yes? Now, if you look on your data booklet, which you don't have yet, you are going to get right now. Take one and pass it around, Anastasia. Start with Nadia. Don't screw it up. If you look on your data booklet, you see right here a rectangular prism. And it even shows you the formula. So let's pretend you don't understand it. Let's pretend that this situation is, I don't get it, Mr. Myers, I can't do it. But at the very least, you're given this formula. HLW. Right? The sides are named, correct? Now go back to our notes, and you see that you have an H, an L, and a W. Does it matter which are H, L, and W?
No.
No, because it's all multiplying. And is 5 times 2 the same as 2 times 5? Yes. So if I make that H, I make that L, and I make that W, I can then fill in the formula, can't I? Even if I don't actually understand surface area, I can always fill in the formula, yes? And if you write out the formula, is it possible to do it wrong? Not really. 2 WL plus HL plus HW. And then you just write it out. W, we made W to be 8. L, we made to be 24. Plus H, we had as 40. L, we had as 24. Plus H, we had as 40. W, we had as 8. Now, punching that into your calculator all in one step is difficult for some of you. So should you try to do it all in one step? Not until you're better at it. Show work. And then it's not hard. 8 times 24, you just do that on your calculator, right? And what is it? It's 192. Plus 40 times 24, 960, yeah?
Yeah.
960. Plus 40 times 8, that's an easy one, 320. Add that up, again using your calculator, and multiply it by 2 to get 1280, 1480 minus 8, 1472 times 2, 1400 times 2 is 2800, 72 times 2 is 144, 2944
Yes.
centimeters squared. Everyone okay with that? You all remember this from the 9th grade, yes?
Yes.
Okay. Nothing changes with surface area in the 10th grade. Nothing changes. You get the formulas and you just work it out. Are you allowed to do it in the grade 9 way? Can you find this rectangle? Write it down. This rectangle, write it down. This rectangle, write it down. And then add it up and then times by 2. Is that allowed?
Yeah.
This is not middle school. This is not elementary school. Do I care how you get an answer?
No.
No. Are you allowed to just use the formula? Yes. Are you allowed to do each rectangle? Yes. Are you allowed to use a combination of the two? Yes. I don't know of any other way to show you how to do it. Is everybody cool with that?
Yep.
Okay. If you're ever in doubt, just look at the formulas. They are there for you. Everyone cool? All right. Turn the page over. This one always messes people up. So I need a rectangle pyramid with base dimensions 32 by 48 and a height of 65. So I need a rectangle on the bottom, yes? 32, 48. Everybody cool with that? Now, of course, this rectangle, if it's a hollow pyramid, it has these in the back, doesn't it? Right? Because it's a rectangle on the bottom. Everyone's okay with that? But when we draw it, we come up to that point. Is everyone all right with the drawing? Everyone's cool?
Yeah.
So the surface area is the outside of it, yes? So what shapes make up the outside of this pyramid? There are triangles. How many triangles, Joel? 4. Are they all the same? No. This is where kids get messed up. Because you want, on your data booklet, did everyone get a data booklet, by the way? There was enough? Okay. On your data booklet, you are given what? A square-based pyramid. What are we looking at right now? A rectangular pyramid. So do you have the formula for a square-based pyramid? Yes. Do you have a formula for a rectangular-based pyramid? No. So you have to apply what you know about geometry to this situation. Everybody with me? Now, if you look on your data booklet, you see that the square-based pyramid, the surface area, is 2bs plus b squared, right? Well, let's think about that for a sec. B squared. That's the bottom, right? B times B. Everyone agree? Yeah. Which is the same as length times width, isn't it? So we can explain length times width. But now we got to look at the sides. We've got this S all of a sudden. Where does that S live in this drawing? It's on the triangles, isn't it? Is it the height of the pyramid? No. When we measure the height of me, how do I measure my height? Do I start the tape measure on the bottom of my foot and go up the side of my body, around my shoulder, up around the edge to here? No, because then I'd be like 8 feet tall. How do we measure height of something? Straight through the middle, yes? So in our notes here today, what am I given? A height of 65. Do I know any measurement of that triangle? I don't, do I? So I got to stop and look at this and say to myself, self, what do I have here? I have this triangle in yellow. Which has a base of 48. Everyone agree? That's not difficult for anyone, is it? Okay. I have this triangle in green. What's its base? 32. Everyone agree? How many of them are there? 2. Yeah? So I'm going to have another green triangle out here, which is 32, and another yellow triangle out here, which is 48, correct? Now, you guys are smart kids. What shape did 2 triangles just make? A rectangle, right? You all know that a triangle is 1/2 base times height, yes? So 2 of them, if a triangle equals 1/2 base times height, and then I multiply by 2, what happens to the 2 and the 1/2?
Just base times height.
Yeah, it's just base times height. They cancel, don't they? So this is just a base times height. And what does that make this automatically?
48 times.
Base times height. Now here's the problem. Do we have a height on the triangles yet? No, we only have a height of the pyramid, don't we? Everyone agree?
Yeah.
So I have this distance at 65, yes? That distance goes from the peak of the pyramid right to the bottom, yeah? Now watch this. What if I do this? Do I have a line up the side now?
Yeah.
What angle did I make right here?
90 degrees.
90 degrees. Do I have some sort of math tool that will find the length of a right angle triangle side?
Yes.
What is it? Pythagoras. Everybody with me?
Yeah.
Now, was any of this new math?
No.
No. Putting it all together is new, though, isn't it? For some of you. So, can I use Pythagoras to find this side, the yellow slant height? I can, can't I? Because I have 65 up top on this leg, 65 squared, plus, what's this leg? Somebody said it. I heard someone say it. 32 divided by 2, which is 16, plus 16 squared. That will get me my yellow slant height squared, won't it? Is everyone cool? Okay, now how do I get the green slant height? Is it still 65 squared?
Yeah.
65 squared plus what? Which is 24 squared will get me my what? My green slant height squared. Is everybody okay with that? Now in Pythagoras, what's the step you're going to forget? You're going to forget the square root at the end. Because you've done so much calculator work and squaring and the numbers have gotten so crazy big, you're going to forget the square root. Right? So I got to square root these at the end. So bust out your calculators and tell me what the two squares, the two slants are. The yellow one is whatever that is, and the green one is whatever that is. The yellow one is going to be around, let's see, 4,242, about 66-ish. Yeah, like what is it really? 66. Oh shoot, I don't want to use blue. 66.9 will do just fine. Everybody cool with that? What's the blue one? Anyone? 69.3? Okay, I'm happy with that. So now, do I have everything I need to solve this? Because this shape is these two triangles, which is just base times height, yes? These two triangles, which is base times height, which I now have, don't I? Right here. And what is the bottom? How do I find the area of a rectangle? Length times width. So what do I really have here? I have base times height for the blue one, plus base times height for the black one. Everyone still okay?
Yeah.
Plus a length times width. What was my base and height on the blue one? 32 and 69.3, yes?
Yeah.
So I got, I should change to blue. I got 32 times 69.3 plus, what's my black one? 48 times 66.9 plus, what is my length and width on the bottom?
32 times 4.
32 by
48.
48. And then I would punch that into my calculator. Now, all your calculators by grade 10 are smart enough to do that all at once. You can just punch it in how you see it. So everybody do so and tell me what you got. It should be in the neighborhood of 2100, 50 and 67 is 3500, 2100 and 3500 is 5600, and 32 times 50, 30 times 50 is 1500, 57. It should be around 7100. 6,900. Okay. 6,900. 64.8. I said 7,100. Am I happy with that? Why am I doing that estimate? Because then when your calculator tells you it's only 11 steps to walk 450 kilometers, you're not going to say, because my calculator said so, are you? Right? I knew this had to be around 7,000 from checking this. How did I check it? I did 30 times 70, 50 times 70, 30 times 50, and then I subtracted a little bit because I rounded most of them upwards. Everybody with me? That estimating will help you. It took me how long? The time it took you to punch that in, I had my guess, yes? Was it worth it to me? Yeah, because now I'm not going to say 11 steps, right? I keep coming back to that one because it makes me so angry.
I don't even see that's possible.
What? The person that wrote 11?
That stupid.
It was an honors student. I won't say anything else. All right. Draw and calculate the surface area of a cone with the radius and a height. So the cone, we know, is the dunce cap from Parveen's school. Right? And we know it's got a radius of 15. Where's the radius? Where do radii live? Center to the edge of what kind of shape, Parveen? A circle. Do I have a circle in a cone? Of course, it's at the bottom. So there's my radius. My radius is what? 15. A height of 22. Where does height live? Middle to the top. There's my H. My H is 22. Now, cones in grade 9, you didn't do officially. They weren't really part of grade 9. Did any of you do cones in grade 9? Be honest, like it's not a put down. If you did cones in grade 9, your teacher was being nice and giving you a head start. They didn't have to. My class didn't. So, if you have never seen a cone, but you're in honors, you know how to work a formula, go to your formula sheet, and what do we see? A cone. And there is the formula for it. Right? Pi r squared pi r s. S, again with the S. Do we have an S?
No.
Do we know how to find it? What finds us S? Pythagoras.
Yeah.
So I got to go back to Pythagoras. I got to go 15 squared plus 22 squared equals S squared. And then I do my math. Go. Jeswin, hold. Take one of these. Go like the wind. What was S while you guys were working? It was 225 plus 441. Is that it? And then square root, what is it? 448. Okay. And so it's going to be 670 something square rooted, which is what? Somebody needs to tell me what S is. I don't want to get out my calculator. I'm lazy. 26.6? I'm happy with that. Sounds about right to me. Everyone cool? Okay, so now I know the surface area of a cone is pi r squared plus pi r slant. Pi, what's r? 15 squared plus pi times 15 times slant, which we now know to be 26.6, yes? Everybody cool? Now, here's something in grade 10 that if you were in my grade 9 class, you were warned of this. Never again is pi anything but pi. Do you understand what I'm saying? It is not 3.14. Is that clear? So, 15 squared is 225, isn't it? So I have 225 pi. Everybody cool? Because 15 squared is 225, then I'm multiplying by pi. Everybody good? Mm-hmm. Plus 15 times 26.6. What's that? Pardon me? 399 exactly?
Yeah.
Cool. 399 pi. Now, I got 225 pies. I got 399 pies. How many pies have I got? $624 pies, don't I?
Yeah.
That is what I want you to do. When you get to here, you are allowed to stop for me. Do you understand what I'm saying? On your provincial, they are going to give you decimals. How do you do this on your calculator? You punch in 624 times the pi button. You find the pi button. It's on your calculator somewhere. And that will give you your answer. On my calculator, it looks like this. 624 times. I actually have a pi button. Do you see it?
Ooh, pi.
Some of you, it will be printed on the calculator. So you got to go shift pi. Okay? You got to figure that out on your machine. Everybody buys a different calculator. It's a super pain for math teachers. If everybody would buy the same calculator, I could say, everybody push here. It would be awesome. But nobody does. So 624 times pi equals. Now my calculator does that. If your calculator does that, you're looking for this button with a circle on it that says change. Hit it, and there you get your decimal. Everybody cool? And you don't do that until the very end. Okay? Everybody with me? Leave pi as pi. Okay?
Okay.
Every time?
Every time. Everybody cool? All right. Your work tonight is try to do number 4. It's a cylinder. And this worksheet. It has one extraordinarily tricky one on it. Okay? Everybody good?
Sure.
What is happening tomorrow? Quiz. Listen to me. Leave a question or two of this blank. So if you finish your quiz early, you have something to do till everyone else is done. Everybody understand?
Yeah.
Okay. Take one, pass it around.